It's one of the extras, and it is number 13.1. Okay, so this is a do a proof. A and B implies this whole thing, B or C and D or A. So, you know, no matter what you're doing, you start your proof the same way, right? Which is you just write down what's my premise. Right? And we know actually, since we've got an implies here, that at the very end we're going to be using a CP, right? Because that's how the implies works, right? What we're going to do is we're going to start with this on the first line, we're going to have that on the second to last line, and then we'll write the whole thing. The book would just do Q and D, right? On the very last line with CP. So far so good? Okay, so let's see where we can get. Do you guys have your list of what the rules are sort of handy? You can look in the book, you have the list, you have something. I don't have it, and we'll see what happens, whether I need it or whether I need to repeat you guys'. All right, but so line 1 is always what's my premise, and in this case, my premise is going to be A and B. And so that's just a premise. Right? And if we have an and in our premise ever, the first thing we do is we try to do the simplification, right? We want to just pull out anybody we can simplify, right? So that means that we can get A based on simplification, line 1 in simplification, right? And we can get B based on line 1 in simplification. And now we're kind of stuck, right? You look and you say, what am I trying to get to? I'm trying to get to implies both of these things. Actually, we might be able to do it without IP, if we know that B is true, right? So this one, let's do, I think we can do this one without IP, I'm not sure. Let's see what happens. Because I'm thinking that there's a rule that says if you know B or A, then you know A or B, right? What's that rule called? Huh? Addition, yeah. Right? So if I say, you know, 4, I could say, let's see, well, let's do the first one. Oops. B or C is true based on line 3 and addition, right? You guys with me? You have the rules out? Okay. Ah, perfect. Okay. Thank goodness for phones. All right. And you guys are all looking at the rules somehow? Yes? Okay. So B or C is 3 in addition, and I think I can also get D or A by 2 in addition, right? So this is one way to do this. We'll try and use IP in a minute just to make a point. Yeah, since you want to use IP anyway. But this is D or A, which is 2 in addition. So I think I can say B or C and D or A by what rule? If I know A is true and I know B is true, say again?
Conjunction.
I couldn't hear you.
Conjunction. The conjunction rule.
I don't think it's called conduction. What's it called?
Conjunction.
Conjunction. Oh, sorry. Yeah, I wasn't hearing you. Yeah, conjunction, right? So that would be from lines 4 and 5 and conjunction. And so now I've got the end, I've got the start. So here's my CP, right? I can say A and B implies B or C and D or A based on 1 to 6 and CP, right? So there's a proof of that, but we didn't use IP, which was the whole point of our trying to use IP. So why don't we try and, once you've copied it down, why don't we try and say, what would happen if I couldn't conclude maybe D or A? Let's do a little sub piece in here. Okay, and see if we can do it with an IP proof, subproof. So are you guys ready for me to erase this and change it a bit? Okay, so there's one proof, and I write QED, and I'm good and happy. Right? But let's suppose that for some reason we got this far and we were stuck. Okay, so for some reason I got the first one. Let's suppose I didn't get any of them. Let's suppose I'm stuck. And I think, boy, what do I need to get? I need to get the B or C part, and I need to get the D or A part, right? Because I need to, I can use conjunction to put them together if I have those two parts. I need them. I don't have them. I'm not sure we can. Can I see the list of rules for a second? Because I don't want to use anything but the, if I know. Oh. So I'm just trying to look at the rules, and I'm trying to figure out, if I want to use IP, right? IP is proof by contradiction, right? So if I want to use IP to prove this thing, the first line is going to be indented. It's going to be something like not B or C, right? But once I've got there, I'm trying to figure out, is there a way for me to get to something that gives me a contradiction without trying to use some of the equivalence rules, right? With only using these guys. So did you have a way? Did you do it?
No,
Use the equivalence rules, yeah. So I'm trying to do it without the equivalence rules. So let's try and do another proof that doesn't use the equivalence rules but does use IP. Right, so using the equivalence rules, yeah, okay, if we're trying, but I may say write a proof that just uses these guys, in which case, yeah.
If you don't say write proof that just uses these,
then you can use the equivalence rules, yeah. So if I say write a proof that uses the, I might say write a proof that uses the basic proof rules, or write a proof that can use the basic proof rules and the additional derived rules. I'll try and be pretty specific. I'll need to look and see what I said now. But yeah, I think on the take home I may have said just use the basic proof rules, right? Is that what I said? You guys have seen the take home more recently than me, but I think that's what I said. Prove it using just the basic proof rules. All right, so let's find another one that has IP in it. Oh yeah, no, that's a great one. Okay, so this is a very similar one. Oh, actually, we can do it with IP. It's just gonna have like a subproof and a sub-subproof and a sub-subproof, right? All right, yeah, let's keep going with this one. I can do it now. I think. Oops, we'll see what happens. If we have not B or C, right, we'll make that a premise, and we'll write for B or C, right, because I'm kind of trying to prove that. Okay. And I could do a sub-subproof here. Right? This is kind of nasty, but you want a sub-proof or you want me to just start? We'll do a sub-proof, we'll see how it goes, okay? Well, if I have not B or C, and what I really want to do is get a contradiction, right? So that I can say it's not in there. If I know not B or C, what if I assume I already know B? So what I want to do is in here somewhere, I want to end up with like a not B, because that'll give me a contradiction, which will let me, right, to this. So how can I get a not, how can I conclude not B? Suppose I want to use IP to conclude not B, so I'm just going to kind of draw a line here so I show what's lined up. I could do a subproof. If I want to prove not B, and I'm using IP, what do I have to assume in order to conclude not B? Not B, right? This is proof by contradiction, right? So let's do another subproof in here, where we'll assume not B as the premise, right? Which will be for not B, right? Am I getting there? So if I say not B, then I've got B, which doesn't help me at all. I thought I had this for a second. Let's see. Then I've got B. Ah, okay. If I say not B is my premise, right? And then I can conclude, so let's see. We'll get the line numbers fixed in a minute, right? So let's see. That's 5. That's 6. So if I know B, right? Maybe I'm wrong here. So what I was thinking I could do is I could say, wait a minute, not B or C, it's not B and not C. I'm going to keep it there. We did this. What were we doing? We did something really clever. I'm not sure that's what I wanted. Oh. Yeah. So what if I say here, okay, so I can say B here. What's my reason for saying B in the subproof? Double negation, right? So that would be line 5 in double negation, right? You guys with me so far? I would not expect you to do this way. But we could, right? So 5 in double negation. If I know B, then I know B or C, right? How do I know that? Addition, right? So that's line 6 in addition. But now I can conclude false because I know B or C and not B or C, right? So I'm going to do false on lines 4 and 7. You guys with me? On line 4 and 7, and what's the reason called? Contradiction. All right. So that means that line 8 can say, I know for sure not B, which is kind of weird, right? And what lines is it based on? It's based on lines yeah, it should. Thank you. Hang on. That was line 7. That was line 8, yeah, and so this is line 9. Okay. And that's not B, which is based on lines 5 to 8, right? NIP, you guys with me? Lines 5 through 8, NIP. Now, here's the interesting thing, right? Lines 5 through 8 have now been discharged. I can't use anything that's in there, right? But if I go to line 10 now, I need to move my microphone, which is probably not doing all that anyway, but we'll see. If I move to line 10 and I'm still indented, I've got not B on line 9 and I've got B on line 3. You guys with me? So I can do false. This is still indented at one level, right? So there's like kind of one level. So this is false based on lines 3 and 9, right? And contradiction. Which means that line 11, I can outdent and I can say I've proven B or C, and that is based on, let's see, line 4 and line 9 and 10, right? You guys with me? Ouch, right? I could repeat the whole same process to conclude D or A, right? Or I could get lazy and say D or A is based on line, 2 and addition, right? If I want to be lazy. And I could finish out the proof the way we did before. So we've got 13, which is B or C, and D or A, which is lines 11, 12 in addition. Yes, yes? And then line 14 is A and B implies B or C and D or A. And that's by CP. Oh dear, that's not good. What did we have? We had touring machine, pumping lemma was the only one that we didn't do. Yeah.
Number 13 is conjunction.
Oh, sorry, thank you. Conjunction. Thank you. So, blah, 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 and that is CP based on what lines? It's based on, right, 1 to 4, and also we get rid of the subproof stuff, and 11 to 13. Right, because we discharge the others, and that's CP, and that's QED. All right, so this is horrible and nasty, and I would not give you one this bad. I might give you something like this bad on the take home, but certainly not. I don't even think I did, but certainly not on the final.